This is a quick demo of my rig and how it works with Ozone Subdivision. This is a facial control rig with no joints and no skin weights, running in control rig with no custom C++, just the nodes available in the graph. Everything's driven by blend shapes and offsets. Before jumping into Unreal, I want to give a quick overview of how the rig was built in Maya. This rig was built using Ozone's biped template, and then I use a set of scripts to intentionally bake it into blend shapes so that we can see how subdivision works on a standard FBX to skeletal mesh workflow. When converting the rig to blend shapes, I also track vertex position offsets where I know the controls will sit, so I can hand that off to control rig later. Now, jumping into Unreal's control rig, I created some custom functions that attach blend shapes to directions along each control's axes. You set the speed, lock it to the control, and auto-import the delta offsets for each blend shape that we exported earlier. Every direction on a control can fire its own shape, nothing tied to weighting, and there's no heavy vertex computation at runtime, just multiplication to set the offset. Also, the shape can move freely and the control just locks into place after. There's still a ton to do, especially around control orientation, but I wanted to throw in a picker and some fun control options. Okay, now for the coolest part. You'll notice the mesh density in Unreal is way higher than what I was rigging on. That's Ozone Subdivision. I'll take the cage geometry, the same exact one all the blend shapes were built on, and in a few seconds, I've got an Ozone Subdivision asset that I can apply at runtime. Now, as I bump the subdivision level up at runtime, you can see I get clean, smooth shapes without having to drag a dense mesh with a ton of blend shapes on it through the entire Maya and Unreal pipeline. Now I can get some really great deformation with no hard edges anywhere and barely any effect on my frame rate. Now, the last thing I wanted to do was map all of the controls to the curve data coming out of MetaHuman Animator. Once I built a mapping of my controls to the MetaHuman Animator curves, I was able to record some video and record the data right to the controls, meaning I could pick up animation right where MetaHuman Animator left off.